Hey, welcome to the Explainer. Today, we're going to fire up the story of an invention that literally powers our world in ways you might not even realize, the diesel engine. So let's just get right into it. But first, let me just ask you this. How on earth can a massive, powerful engine run on something like peanut oil? Well, the answer isn't some new age discovery. It's actually a story that goes back over 100 years to one brilliant idea that completely changed the game. You see, our story starts not with a bang, but with a puzzle. How do you create that controlled explosion you need for an engine, but get this, do it without using a spark? Okay, so let's set the scene. We're in the late 1800s. A German engineer, a guy named Rudolf Diesel, is working like crazy on this problem. By 1892, he totally cracks it, and just a year later, he patents his diesel cycle. Fast forward to 1900, and he's at the World's Fair, ready to show his invention to the world. And this is where the peanut oil comes back in. He actually demonstrated his engine running on it right then and there, proving just how versatile this thing was from day one. But here's what's really fascinating. You want to know what Diesel's original goal was? He wanted to build an engine that could run on Germany's most abundant resource, coal. His dream was to free his country from relying on imported petroleum. His very first designs tried to use coal dust as fuel. But yeah, the ash from the coal just wrecked the mechanics, so he had to pivot. Diesel's vision, though, was absolutely huge. He saw his invention as way more than just an industrial machine. He saw it as the future of how we get around. And his truly revolutionary idea was this: get rid of the spark plug. He wanted to create combustion using a totally different force. So, how in the world do you make fire without a spark? The answer isn't about some fancy chemical. No, it's this incredibly elegant solution that's all about pure physics. Extreme, and I mean extreme, pressure. This right here is the secret sauce. It's called compression ignition. Now, unlike your regular gasoline engine, which mixes air and fuel before it gets compressed, a diesel engine does something different. It starts by sucking in only air. Then it squeezes that air with just an incredible amount of force. And the result of all that squeezing is just staggering. By compressing the air down to about 1/25th of its original volume, the temperature inside that cylinder skyrockets to between 500 and 700 degrees Celsius. To put that in perspective, that's hotter than the surface of Venus. When it's that hot, you don't need a spark. And this all happens in this beautiful 4-stroke cycle. First, you have the intake stroke, where the piston just pulls in fresh air. Simple enough. Second, the compression stroke squeezes that air like crazy, making it super hot. Third, and this is the magic moment, fuel gets injected and it instantly explodes. That's the power stroke, which slams the piston down with massive force. And finally, the exhaust stroke pushes all the used up gases out, and the whole thing starts all over again. It's powerful, it's efficient, and there's not a spark in sight. Now, of course, the engine powering a modern semi-truck is a whole different beast from Rudolf Diesel's first prototypes. The core idea is exactly the same, but, 100+ years of innovation has made it way smarter, way stronger, and way more efficient. One of the biggest changes was in how the fuel actually gets into that super hot air. The early engines used something called indirect injection. They'd spray fuel into this little side room, or pre-chamber. It made the engine run a bit quieter, but it was inefficient. You'd lose a lot of heat. Today, the standard is direct injection, which, like the name says, shoots the fuel right into the main cylinder. It gives you a much more powerful and efficient burn. The engine's brain also got a serious upgrade. I mean, we're talking a massive leap. Early diesels were controlled by a mechanical governor, which was this clever setup of gears and springs. But today, it's all run by a super smart computer called an electronic control unit, or ECU. It uses all these sensors to fine-tune the fuel injection timing down to the microsecond, squeezing out every last bit of power and efficiency. And if you want to get the most power out of every single drop of fuel, well, you need more air. And that's where the turbocharger comes in. It's a brilliant device that uses the engine's own exhaust, basically waste gas, to spin a tiny turbine that pumps way more air into the cylinders. Then you add an intercooler to chill that air down, making it even denser, and bam, you get a huge boost in both power and efficiency. But this story of incredible power and efficiency comes with a pretty big catch. The very thing that makes a diesel engine so great, that unique combustion process, also creates its biggest modern-day problem. See, because the fuel and air have to mix and explode in just a fraction of a second, the combustion isn't always perfect. It can be incomplete. And that process can create pollutants, like soot and nitrogen oxides, which have become this huge environmental challenge that engineers have been working to solve for decades. And on top of emissions, diesel has another old enemy: the cold. When the temperature really drops, the paraffin wax that's naturally in diesel fuel can start to crystallize and thicken up. They call it gelling. It basically turns the fuel into a thick sludge that can clog up the fuel lines and make it really, really hard to start the engine. But engineers, for every problem, they've come up with a solution. To help out with those cold starts, you've got glow plugs, which are like tiny little electric heaters right inside the cylinders. There are fuel heaters to keep the fuel itself from turning to goo, and in the absolute coldest places, you can even plug in an external block heater to keep the whole engine block toasty warm while it's parked. So after well over a century, what's the big picture? The story of the diesel engine is really a masterclass in engineering, a story of constantly evolving and adapting to whatever new challenges come along. So let's just boil it all down. At its core, the diesel's magic trick is making fire without a spark, just using the incredible heat you get from extreme compression. We've seen it go from a clunky mechanical machine to one run by a tiny, powerful computer. And its whole modern story is this constant balancing act between its raw efficiency and the absolute need to be cleaner. When you think about it, it started as a dream to run an engine on coal dust, and it became a global workhorse that runs on everything from petroleum to peanut oil. It's been absolutely relentless. So as we look ahead to new fuels and even stricter standards, the big question is, what's the next chapter for Rudolf Diesel's brilliant idea?